Okay, guys, welcome back. We are going to be talking about measures of variability today. You are in the same packet, which is the Unit 11 packet, packet number 1, and we are going to start on page 23. Okay, so if you can see that here, page 23. I'm not worrying about this right now. We're just going to first talk quickly about a review of the concepts we've already talked about. We've talked about measures of central tendency. Okay, and those would be mean, median, and mode. Okay, so those are our measures of central tendency. We've talked about shape. Okay, and when something is either skewed to the left, which means the mean is less than the median and mode. We've talked about when we're skewed to the right, and that's when the mean is greater, right, than the median and mode. And then we've talked about when we're approximately symmetrical. See if I can spell that. And that means that the mean is approximately equal to the median. Okay? And then we had our bimodal, right? And then we talked about outliers. Okay? So that's kind of where we are up until this point. Okay? So today we are going to talk about measures of variability. Now, if I can get there, let's see, we're on page 24. My ink pen is running out. I'm trying to find a new pen here real quick. Let's see, give me a minute. Oh, I found one. Okay, let's see if this pen works better because that one is almost dead. Okay, measures of variability. The spread, oh, much better. The spread of the data, okay? So first we're going to talk about, we'll talk about two measures of variability really this unit. We're going to talk about range, which is the difference between maximum, and minimum data point. Okay, so that's the range. So you take the max minus the min. And then we have standard deviation. And this is, let's see, the typical or average distance, which we call more often than not deviation, from, and this is important, the mean, okay, I'm going to put that in caps, that we expect the majority of the data values to fall within. Okay, and in a little bit, we're going to talk about how you calculate that standard deviation on your calculator. And I just want you to remember S sub x on the calc. Okay, that is going to be your standard deviation. Okay, it's S sub x. So make sure you know that. And also, I want you to highlight this, circle it. Remember this. These are your instructions at the bottom of page 34 that tell you actually how to use your calculator. When calculating, you're going to find not just standard deviation, but that's what we're talking about, but your mean and your median. It does it all for you. Okay? We are on page 25. Okay. This picture right here is what we call a standard bell curve. Okay, you've probably heard or seen this in the news before when we, oopsie, I can't spell, when we talk about a bell curve. Okay, and if you look at that red part right there, that's about 68% of the data. If we talk about going out to the green, okay, so let's see, out to here, that is about 95% of the data. And then if we go all the way out here to the edges of the blue, out here, all the way to here, that is about 99% of the data, okay? And that's a standard bell curve, okay? I'm not going to talk too much about this because I think this is confusing, but what I do want you to take away from this is that they tell us, you can't really, this is hard to decipher, but they tell us the standard deviation on this is 2 crackers. So this must be talking about crackers. And they give us that the mean, and remember I always say the mean is the x with the bar over it, the mean is 21 crackers. So when I ask you to find the standard deviation, Well, here they gave it to you. They say it's 2. And you're going to take the mean, and you're going to do plus or minus. So mean plus or minus the standard deviation. Okay? When you do 1 standard deviation, that means you're talking about 68% of the data. So in this red, when you're talking about 2 standard deviations, you take your mean and you're going to take 2 standard deviations. And that's going to get you at 95% of the data. Okay? And then 3 standard deviations, that's going to get you 99% of the data. So you would expect on these crackers here that if we take the mean 21 and we add the standard deviation of plus or minus 2, that's going to be 21 plus 2 is 23. 21 minus 2 is 19. So you would expect that 68% of the data would be between 19 and 23 crackers. Okay? If you do 2 standard deviations away, well, 2 of those would be 2 plus 2, which is 4. So now we're going to get from what? 17 to 25. So we would expect that 95% of the data would fall into the range of 17 to 25 crackers. Okay? And then 3 standard deviations would be 6. So 99% of the data is going to be 15 to 27 crackers. Okay, so that's where you kind of use it. You're looking to see where all your numbers fall. Okay, let's go in its most basic sense. Let's go on to page 26. Okay, and you can see here that we have a mean. Okay, and this is just another standard bell curve. We've got 68.3% of the data is plus or minus 1 standard deviation. 95.4% is plus or minus 2 standard deviations, and 99.7 between plus or minus 3 standard deviations. So you can kind of see where everything falls. So let's look at example 1. If the mean of your science test was 80 with a standard deviation of 10, so they're telling us what that standard deviation is, what would your science teacher expect the grades to be for this class? So if we take 80, remember you're taking your mean, and they're saying it's a standard deviation of 10, so that's plus or minus 10. You're going to subtract 10, and you're going to add 10. Okay? What that tells us is that 68% of the students are going to score between, because that's a standard bell curve, 68% of the students are going to score between 70 and 90%. Okay? If you go a step further and you do 2 standard deviations, then we'd subtract another 10 and add another 10, and that would give me 60 to 100. And that would be 95% of the class is going to score between 60 and 100. Okay? So we can write for this class, typically, we'd expect, let's see, let's say quiz scores, I'm abbreviating here, of 70 to 90, inclusive, 68% of the time. Okay? And same thing, and scores of what? 60 to 100, inclusive. I always say inclusive. 95% of the time. Okay? So that's kind of what the standard deviation tells us, okay? Example 2, if the mean of your English test was 90 with a standard deviation of 4, what would you expect? Well, now our mean is 90. Our standard deviation is 4, so we're going to subtract 4 and add 4. That's going to give me 86 to 94. And that's going to be, let's just do this, 68% of the data is going to fall between those scores, or 58% of student scores. If I want to do 2 deviations away, minus 4 plus 4, I'm going to get 82, to 98? And that would 95% of students would get that score, okay? We don't need to write all that out again. If Joe received an 85 on his science test and an 85 on his English test, on which test did he do better? Well, let's see. He scored an 85 on his science and 85 on his English. So here's science. So 85%, let's see. An 85 would be in here. Here an 85 would be here in the 2 standard deviations. So he obviously did better on the science, okay? And why is because, so 85 on science is better because it is within one standard deviation of the mean. Okay, the ELA score of 85 is 2 standard deviations from the mean. So better, in conclusion, better on science is what I would say. Okay, let's go to page 27. Okay, graph of attendance. So here we have our curve, and it looks like it's going to look something like this. So I hope you recognize that that's skewed to the right. Okay, what is the appropriate measure of center for this data? Okay, I think you should recall, I hope, that in the last video I talked about the fact that when it's skewed left or right, more often than not, the median is going to be the appropriate form of measure, and that's because the mean is impacted by that outlier over there, is impacted by possible outlier of, what is that, of 23 days absent. So that's going to affect that mean and skew it. Okay, and let's see, what was our mode? Our mode was 1, right? That's the most frequent. Write a paragraph describing the distribution of first semester absences for these 50 students. Include analysis of measures of center, shape, and spread with numerical support. Okay, so let's see. When we talk about shape, I already said it above, it's definitely skewed right, okay? And that's because we also want to say always with the possible outlier, 23. The spread, so that was the measure of a center, the measure of center. If we talk about spread, well, we can do our range, right? Our range is our max minus our min, so that's 23 minus 0. So we have a spread or a range of 23. Most student absences, ENCES, sorry, or number of days, tend to be within plus or minus 1 standard deviation of 1 day absent, okay? Because if you look at it, if you're at, right, if you're within 1, you've got most of the data there, okay? So that's why I put within plus or minus 1. Let's go on to page 28. We're in the home stretch here. Okay, let's look at this bottom. Class 1, Class 2, Class 3. Cross these off for me. I want to talk about the analysis here, discuss the shape, variability, etc. Okay, I always draw in, I kind of trace it so I can see what it looks like. Okay, you should see that this is the shape. I would definitely say it's skewed right. Okay, you can see that tail to the right. So it's skewed right. Standard deviation, okay, I'm going to show you in a second how to do that. Give me a second. What that means is that the mean, because we're skewed right, the mean is going to be greater than the median and mode, okay? The range, and that's our spread, right? Our range is going to be, what, 10 minus 2? And let's talk about how we're going to get the standard deviation, okay? Everybody got their calculators. Turn them on. Okay, I want you, and again, those instructions I said were on the previous page, page number 24, if you want to follow along there too. Okay, you're going to go to stat. Okay, I'm going to give you a second here. And the first one's edit. You're going to press enter. Okay, I'm going to clear out my data. And if you don't remember how to, just highlight L1, press clear, and then press the down button. Okay, let's see if I can get this focused a little bit better. Oh, that's better. Okay, I'm going to enter in all my data points, okay? So I have a 2. I have, look at that, 2 3s, so 3, 3. I have 1, 2, 3, 4, 5, 6 4s, so 6 4 times. Or sorry, 4 6 times, I should say. 4, 2, 3, 4, 5, 6, okay. I have three fives, so 5, 5, 5. I have 1 6. I have 1 8, and I have 1 10. Okay, so I have all my data in. Now, the calculator does everything for you. You are going to go to stat again. You are now going to go over to calc. The first one's highlighted. It's 1 var stats. Press enter, 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 and it's going to calculate everything for you. And remember I said S sub x is your standard deviation. It's 2.01. So we're just going to say standard deviation is approximately 2. It tells you what it is. If you want to see something else, which I think is kind of neat, the x with the bar over it, that is your mean, and the mean is 4.7. Okay, so it gives you those kinds of data points, but it doesn't ask for that, so we don't need to write it. So that's what I would do on that one. Okay, on this one, our shape is symmetrical, right? Can't get much more symmetrical than that. Okay, which means our mean equals, well, this one's exactly, mean equals median equals mode. The spread, we don't even have to do this because is there any spread whatsoever? No, there's no variation. So I don't have to calculate it. I can see it's 0. And on this last one, let's see, we got a right there. We are going to have something that's, again, approximately symmetrical. Okay, which means they're all approximately equal. The range is going to be 6 minus 3, which is 3. Our standard of deviation, okay, I can tell you right now it's 1, but if you want to calculate that, go back into your stat, edit. We're going to clear out our table, and we're going to enter our data points. 1, 2, we have 3, oopsie, I messed up somewhere. Stat, edit, there we go. Okay, we've got a 3, 3, 3, 3. So we have 4 3s. Then we have 1, 2, 3, 4, 5, 6. 6 4s. We've got 3 5s and 2 6s. Okay, got it in there. I go back to stat. I go to calc. I go to the first one, which is 1 var stat. Calculate, and standard deviation of approximately 1. Okay, so I'll do that right there. And a standard deviation of plus or minus 1 will capture most of the data points. Okay. Just looking to see what I want to do here. A couple more things. If you turn to page 29, okay, we have a dot plot here that shows the number of minutes, 30 flights made by 2 airlines, okay? If you look at this one, kind of see there's my curve. Okay, on this one, it's a little bit more, we got data all the way out here, okay? So they just put 2 different sets of data on the same dot plot. Okay, note, negative numbers represent minutes the flight arrived before its scheduled time. So if you were there early, 0 is you're right on time. If it's a positive area, it means that you were over and you got there late, okay? Complete the following chart. Measure, okay, let's do airline P first, which is the top one. Measure of central tendency. Well, I would say that this is a pretty symmetrical shape. So I would say that the mean is approximately the same as the median, approximately the same as the mode. Okay, and we can see right away that our median looks like 0. Okay, but we don't have to calculate that right now. I didn't ask for it. So because, oh, we're not doing this one yet. Look at the shape. I already told you, whoops, approximately symmetrical. Okay, and the range, we're not going to, let's see, we got negative 25 to 25, so range of 50, I'd say, right? 25 minus a negative 25 is 50. Okay, on C, we have, I would say, a skew to the right because we have that tail, right? So that means, and with, let's put a possible outlier. Look at that outlier way out there, 60 minutes over. Wow, possible outlier at 60. Okay, Got our mean then, if it's skewed right, it means our mean is greater than our median. Okay, and our range is going to be what? 60 minus negative 35, so 95. Okay, and I'm not going to make you find the standard deviation right now. Based on this data, from which airline will you choose to buy your ticket? Well, I hope you see that you should choose airline P. I would choose P because there is less variability. Okay, in arrival times, we'll say. Airline P gives you a better chance of arriving within 10 minutes of your scheduled arrival time, right? So that's the one I would pick. Okay, last thing I want to do is page 32. So I've skipped a couple pages over. And I'm not going to spend a ton of time on this, but there are going to be some homework problems like this. So I want to make sure you understand it. Look at 4. It says, the mean weight of a football player on Cedar Falls High School varsity team is 198 pounds. It gives you the standard deviation of 18, okay? So what we're going to do here, sorry, my Chromebook is acting funny. Here we go. Okay, so what I'm going to do here is I'm actually going to take my mean, which they give me, which is 198, okay? And I'm going to do plus or minus the standard deviation of 18, which is going to give me equals either 180 or 216, okay? So I can say that the weight of the majority of varsity football players, we're going to say VFB, is between 180 and 216 pounds inclusive. And remember, when I say majority, that means about 68%, okay? Because that's that bigger part, the middle of the bell curve, okay? And then if I say, would it be likely for there to be a 240-pound football player on the Cedar Falls team? Well, we've got our 180 to 216, right? If we did 216 plus another 18, so 2 standard deviations away, we'd be 234. If we subtracted 18, we'd be at, what is that, 162? And they want to know how much, 240? Oh, no, so we can say the weight of 240 pounds is more than 2 standard deviations from the mean of what? 198 pounds, i.e. 95% of football players, we're going to abbreviate, weigh, oopsie, GH, weigh between 162, that should have been a 2, 162 and 234, okay? So no. So the answer is no. It's going to be way outside that bell curve, okay? And finally, 5A, just make sure that you type all those data points into your calculator and let the calculator do the work for you, okay? Especially on standard deviation, make sure it's S sub X, okay? And your, you should know everything else. The mean is the X with the bar over it, okay? And the median and mode, you can calculate it on your own pretty well, okay? Hope that helps.